So for this problem, we're looking at an automobile dealer. He sells 12 cars a day at $13,000. He estimates that if he reduces the price by $300, he can sell 2 more cars per day. So we have to set up 2 different functions. We have to set up a function for price, and we have to set up a function for quantity. So we're going to let X be the number of $300 price reductions. So for price, we are currently selling the cars for $13,000, and we're looking at a $300 price reduction. So 300X because X is the number of $300 price reductions. It's minus because we're reducing the price by $300 for each vehicle. Now, for quantity, right now we're selling 12 cars, but we think if we reduce the price by $300 per car, then we can sell 2 more cars. So 2 cars for every $300 price reduction. So we need the rest of this information that's in this problem about cost, but we'll come back to it because we're trying to maximize profit, and to maximize profit, we need revenue and we need cost. So we'll find revenue and then come back and find the cost. So to find revenue, what we have to do is we have to multiply price times quantity. So we found a formula for price. We're going to multiply price times the formula we found for quantity. Okay, so $13,000 minus 300X is here, and we've made a product with Q of X, which is 12 plus 2X here. So our next task is to multiply these two together. So 13,000 times 12 is 156,000. 13,000 times 2x, 26,000x. Negative 300x times 12, negative 3,600x. And negative 300x times 2x, negative 600x squared. So from here, what we need to do is we need to combine like terms. Our like terms are right here in the middle. 26,000 minus 3,600 is 22,400x, and we've just recopied the 156,000 and the negative 600x squared. So now that we've found revenue, in order to maximize profit, we also have to find the cost. So it says in the problem that each car costs $10,000, and there's a fixed cost of $1,000. So what we have to do is we have to multiply $10,000 times the quantity, because it's $10,000 for each car. So $10,000 times the quantity, 12 plus 2x, plus the fixed cost of $1,000. So now we will distribute 10,000 inside the parentheses here. So 10,000 times 12, 120,000. 10,000 times 2x, 20,000x. Then we need to combine like terms. Our like terms, 120,000 and 1,000 makes 121,000 and plus 20,000x. So now that we have revenue and cost, we can finally find the profit function. We find the profit function by subtracting cost away from revenue. So you see here we have our revenue function that we found earlier and our cost function that we just found. We need the cost function in parentheses because we have to subtract all of the cost function, not just the first term of it. So our next step is to distribute this negative inside the parentheses. Negative 1 times 121,000, negative 121,000. Negative 1 times 20,000x, negative 20,000x. So then we have some like terms that we can combine. We have 156,000 minus 121,000, which leaves us with 35,000. We have 22,400x and negative 20,000x, which leaves us with 2,400x. And we just recopy the negative 600x squared. So now that we've combined like terms, we can take the first derivative of profit. So the first derivative of 35,000 is 0. The first derivative of 24,000x is just 2,400. And the derivative of negative 600x squared is negative 1,200x. So from here, we set the first derivative equal to 0 and solve to find the value of x that will maximize profit. So to begin, after we set it equal to 0, we need to add 1,200x to both sides. Then we'll divide both sides by 1,200, and that gives us a value of x equals 2. So just to double check to make sure that we actually have a maximum, we'll do a second derivative of the profit function. So if this is the first derivative, then the second derivative is just negative 1,200, which is less than 0, so there is a relative max at x equals 2. So the question asks, what price does the dealer need to ask for each car in order to maximize profit? So we take x equals 2 and we plug it into the price function that we made. So our price function was 13,000 minus 300x. We plug a 2 in for x. Negative 300 times 2, negative 600, and 13,000 minus 600 is 12,400. So that is the price that will maximize profit.